In this video, we are going to do introduction to logarithms. Let's start by getting the exponents for these values given. 10 raised to what power is equals to 1003. So we get 3. 5 raised to what power is 625. That's going to be power 4. This is going to be power 4 to get 81. And this is going to be negative 1/2 because it is square root, and but then it's a fraction. Negative, there's a fraction, so it's going to be negative, and then raised to power 2, and this one is the cube root of 125, so it's going to be a third, and this one 7 raised to power 3, and this one is going to be 3/2 to get 64. So now the next one, and we know because the cube root of the square root of 16 is 4, then we cube it, so we get 64. So now here we are going to move to find a pattern, and we are going to move from exponential to logarithm form. So here we are going to write logarithm, and we are going to write to base 2 of 32 is equals to 5. So here what we are saying, 2 raised to power 5 is 32. So 2 raised to 5 is 32. Now let's go to the next one. So the next one we're going to say logarithm, and what is our base now? 3. We raise it to power 4. We get 81. So again, I want you to see the pattern. 3 raised to 4 is 81. The next one, logarithm to base 4 of 1/16 is equals to -2. So again, we are saying 4 raised to -2 is equals to -16. Then I go to the next one, logarithm to base 5 of 125 is equals to the exponent. So logarithm to base 10 of 1/100 gives me the exponent. Remember the exponent I was looking for in the examples above? And then logarithm to base 81 of 9 gives me 1/2. So from what we can see here, when I'm looking for the logarithm to base 2 of 32, it gives me the exponent I was looking for. So when we are looking for this exponent, another way of saying it is looking for the logarithm to that particular base. So logarithm to base 4 of -2 gives me -116. So what I'm saying, 4 raised to what power gives me 116, and that gives me the logarithm value. 5 raised to what power gives me 125. So that number I'm getting is the logarithm value. So the logarithm value gives me the exponent to which a base must be raised to give a certain number. So here you can see if I have a base raised to an exponent, I get a result. And see if I have log base, the result then gives me an exponent. So the logarithm to base of a result gives me the exponent I'm looking for. Okay, now let's look at the definition of a logarithm. The logarithm of a number is the exponent by which another fixed number, a base, must be raised to produce that number. In general, if you have b raised to n gives you x, then you can express it as a logarithm by writing it to logarithm to base b of x is equals to n. So here is the definition of the logarithm. Now we are going to do the same thing we started with, but now we are using the logarithm. So here, 2 raised to what power is equals to, so 2 raised to 4. So x is equals to 4. So x is equals to 4. If x is 4, I get 16. 12 raised to -2, what do I get? And this one, the result, here I'm looking for the result. So 12, you raise it to -2, and this is going to be, y is going to be 1 over 12 squared, which is 144. Whenever you see the negative, it's going to be a fraction. So here you're looking for the base. b raised to power 3 is equals to 216. So what must be the b? b has to be 6. And here, 2 raised to a is 1 over 32. So we know a has to be, we know 2 raised to 5 is 32, but I want it to be a fraction, so a has to be -5. And then 3 raised to z is equals to 3. 3 raised to z is equals to 3. So z has to be 1. So here we are going to evaluate logarithm, and we are not going to do the graphing at this point. So definition of a logarithm to base b, let b and y be positive numbers, and b cannot be 1. So this base cannot be 1. The logarithm of y with base b is denoted by, so remember when you're looking for logarithm, you're looking for the exponent of y with the base b. This is the way it's written, and this is the way it is defined. Logarithm to base b of y is equals to x, even only if b raised to x is equals to y. And we read it as log base b of y. And now, since we are told the exponential and logarithm forms are equivalent, let's go and write in exponential form. 2 raised to 5 is equals to 32. 10 raised to 0 is equals to 1. See the way I'm going from here and then back there. Then 9 raised to 1 is 9. 1 over 5, you start with a base, 1 over 5, you raise it to -2, and then you get the result, which is 25. Okay, so now evaluate the logarithms. So when you're evaluating the logarithms, we are saying 3 raised to what power is 81, and that's going to be 4. 10 raised to what power, remember you could write it as an exponent, 10 raised to what power, which I can call x, is equals to 1 over 1,000, because that's the same thing. So here, this is going to be -3. The next one, you are saying 64 raised to what power is going to give you 2. And this is going to be 6th root, so it has to be 1 over 6.